Hello students, good morning. Welcome to the next topic. Here in this class we are going to learn regarding the Nernst equation. Here the definition of the Nernst equation is the variation of electrode potential with concentration of metallic ion in solution is given by the Nernst equation. Okay, so what the definition of Nernst equation here? The variation of electrode potential. Variation is nothing but the change in electrode potential with respect to concentration of metallic ion or the non-metallic ion in solution is given by the Nernst equation. So did you got the definition here? The Nernst equation. Nernst, he is a scientist. He has given the one equation in order to give the relationship between the electrode potential and the concentration. So here the Nernst equation is going to explain us how the electrode potential will change with respect to that of your concentration for both the metal and as well as your non-metal ions or electrodes, simply we can call it, right? So that is we call to as your Nernst equation. Now what the Nernst equation is here? The Nernst equation is given as E equals to E naught minus RT by NF ln product concentration by the reactant concentration. Okay, for the Nernst equation here it is E equals to E naught minus RT by NF ln concentration of product by concentration of reactant. Here the terms are given here. See, E is nothing but called to be as your electrode potential of a cell at different concentration. So whatever the electrode potential is there for a cell, that is taken to be as your E, and E naught is called to be as your standard electrode potential, that is your E naught is taken to be as standard electrode potential. And R, we know that it is nothing but your gas constant whose value is 8.314 joules per Kelvin mole. Okay, and T is nothing but your temperature, that is your absolute temperature. So in case of your Nernst equation, most of the time the temperature is assumed to be as your 25 degrees Celsius. That is nothing but the 25 degrees Celsius temperature is simply called to be as your standard temperature, is called to be as your standard temperature for the Nernst equation. So most of the time it is taken to be as your 25 degrees Celsius. So this 25 degrees Celsius we have to convert in the form of Kelvins. Therefore we are going to add to here 273. So it is not only the 25. The temperature value is never means it does not only be the, it doesn't only be the value of 25. It can be some other temperature also, but for the standard temperature is taken to be as your 25 degrees Celsius. Sometimes in problem they may give you some any other temperature. Okay, but the standard temperature we are going to assume it as your 25 degrees Celsius. And N is nothing but the number of electrons involved. So in the reaction, how many number of electrons, what is the number of electrons involved in an electrochemical reaction, that is taken to be as your N. And F is called to be as your Faraday's constant or Faraday's value. That value is your 96,500 coulombs is the value of your Faraday's. Okay, now let us check here. See here the one more form here, that is E equals to E naught minus 0.059 by N log concentration of product by the concentration of reactant. So what the difference between this relation and this one here? The relation is that here they have substituted the value of R, temperature, that is your 298, and the F value, that is your 96,500 coulombs. So after the substitution of value of R, T and F, so whatever the calculation, the final value which you are getting, they have taken here, that is your E equals to E naught minus 0.059 by N log of concentration of product by the concentration of reactant. So this is also called to be as your Nernst equation, but this equation will be used only in the case if the temperature is your 25 degrees Celsius. If it is only the 25 degrees Celsius, then we are going to proceed with this Nernst equation form. But if it is anything other than 25 degrees Celsius, then we are going to take this equation. So here already they have calculated the value for T taken to be as 25 Celsius. That's why it is at the standard conditions. Okay, so this is the introduction regarding your Nernst equation. Now let us see how to write the Nernst equation for the metal electrodes. So here I'm going to take the one reaction. The reaction takes place at the cathode is M plus N plus N electrons gives metal. So what is the reaction here? The reaction is, it is an metal cation accepting the electron. Nothing but the exception of electron is simply called as your reduction, right? So here the metal cation undergoes reduction to form the metal. Now for such reaction, how to write the Nernst equation? Here it is given here, see. The Nernst equation for this reaction is E0 E equals to E0 minus 0.059 by N log of concentration of M by concentration of M plus N ions. So why we are writing the plus M here? See, as the formula it is given here. What is the formula here? It is the concentration of product. So what is the product we are going to obtain here? That is M. That's why I take it as M. And the reactant here is nothing but your Mn plus. That is the Mn plus. Here electrons we are not going to consider. Only the metals and the ions we are going to consider to write the Nernst equation. The electrons will be considered only in the case of N values, right? But here we are not taking this one. That is only the, our concentration is only on product and the reactant. That is here, right? So from this we can derive to as E0 equals to 0.059 by N log of 1 by Mn plus. So why the concentration of M is taken to be as 1 here? Because the concentration of metals, nothing but simply the solids, is always going to be the 1. The concentration of the solids is always taken to be as 1 in Nernst equation. That is the value is going to be a 1. Okay, so this is your Nernst equation for the metal electrode, that is E0 minus 0.059 by N log of 1 by Mn plus. Okay, so how you can write the Nernst equation here? Final form, that is E equals to E0 minus 0.059 by N log 1 by Mn plus. Okay, so you have understood why the concentration of metal is taken to be as 1 here, because in Nernst equation the concentration of solid is always taken to be as 1. Okay, that is here. Now let's check how to write the Nernst equation for the non-metal electrodes. So here I'm going to take one non-metal electrode reaction where A is your non-metal. Okay, it's going to have A plus Ne electron, nothing but n number of electrons. Nothing but what is happening here is going to gain the electron, therefore is going to form the A minus N ion. Now for this, how to write the Nernst equation here? See, we know the standard form of equation, that is E equals to E0 minus 0.059 by N log of, what you write here? Concentration of product. So what is the product here is, that is A power minus N. And what you write in the denominator here? Concentration of the reactant, that is nothing but A. And here the one more point to be noted here is, here also the concentration of non-metal, that is A, will also be the 1. Therefore the value of is going to be the value of A is going to be the 1. Here is going to be the 1. Therefore only the equation is taken to be as E equals to E0 minus 0.059 by N log of concentration of A power minus N. Okay, that is the how to write the Nernst equation for metal and as well as your non-metal electrode. Here by using the Nernst equation we can find the difference between the electrode potential of two electrodes. Means we can find the difference between electrode potential of two electrodes. So how it is possible here? By using this relation, that is here E cell equals to E cathode minus E anode, where E cell is nothing but the overall potential of a cell, are simply called as EMF, and E cathode is nothing but your reduction potential of cathode, are simply called as your potential of cathode, and E anode is nothing but reduction potential of anode. Is it clear, this one here? So if you want to write the Nernst equation for the Daniell cell, in the previous class we have learned regarding the Daniell cell. So from that we can write this one here, that is E cell equals to E0 cell minus 0.059 by 2 log of concentration of Zn plus 2 by Cu plus 2. So how can you write this equation here? See, we know one form, that is there we have learned what you have written there, that is Zn forms Cu plus 2 is going to form you the Zn plus 2 plus Cu, right? So this is the reaction what we have written. Now as we know that it is the concentration of, here we are going to the concentration of product. So what is the product we are getting here? That is Zn plus 2 ion and the copper metal. So this is a solid form, therefore the concentration is 1. That's why directly we have taken to as concentration of Zn plus 2. And here in the denominator it will be the concentration of your concentration what you are going to take here. Here we are going to take regarding the reactant. So in the case of the reactant, so what we have here, that is Zn and the Cu plus 2. Here Zn is again the solid metal, therefore its concentration is 1, therefore we have taken this only the Cu plus 2, right? So this is how you are going to write the Nernst equation for the Daniell cell, right? Is it clear this one here? So this is the topic related to the topic here, Nernst equation, that is from the point number 126 to 131. Okay, so these are the points. Generally this answer is also there in your study material, but it was somewhat long, so I got this answer here. It is somewhat easier and also in the terms of points and also short answer, right? It is very short only because it is given in terms of points. One of the important answer, you can learn this one. Okay, if you have any doubts regarding this answer, so tomorrow we have at 3 o'clock we are going to have the online video conversation where you can clear your doubts on the Zoom app. If you're not yet downloaded the Zoom app, download it. Tomorrow at 3 o'clock we will have the chemistry online video class where you can share your doubts. I will be explaining that. Okay, thank you.